said that you would like to do some science experiments, and I thought about what I would do and show you, and I decided I was going to talk to you about electricity and magnets. I thought you'd like to hear about electricity and magnets. So I'm going to tell you about electricity and magnets, and I'm going to do some experiments right in front of you. I'm going to show you what I'm going to do, and I'm going to do it, and then I'm going to give it to you, and you're going to do the experiments. So I'm going to do them first, and then I'm going to come around at the end when I'm done showing you. I'm going to put them right on your desk, and then you guys can do one experiment, and I'll put an experiment over there, and you can do your own experiment, and you can do your own, and then when you're finished, you can switch around and do the other experiments. I'll do them first, so you got to pay attention so you know what to do, because otherwise there'll be wires and things, and you wouldn't know how to do the experiments. Okay? Okay. I'm going to talk to you about, well, I'm going to start with electricity. I'm going to tell you about electricity. Two kinds of electricity. One kind of electricity is wall electricity. You all plug things in at home, don't you? You plug them in, and they work like what, for example? What works with electricity? A light. A light. What else? A lamp. Where does electricity come from?
The wall.
How does the wall get the electricity? How does the wall get the electricity?
From a pole that gives electricity.
From a pole. Well, the pole throws the electricity and the wall catches it? I mean, how does it get from the pole to the wall? It's a wire. The wire goes from the pole to the wall. Now you know what the next question I'm going to ask is? Where did the pole get the electricity? Uh-oh. Where did the pole get the electricity? Anybody ever think about that? Anybody have any idea where the pole got the electricity? Yes? No, actually, the electricity goes into the box and comes out of the box and goes into your house. But how does it get into the box? It comes from the pole. Where does the pole get it? Yes?
From the line.
From the line. You ever see the wires outside when you're driving along? Those wires that go from pole to pole? You know, those are the things that bring the electricity to the wall. Where did the wires get the electricity from? It's a hard one, isn't it? I'm going to tell you what they get. Do you know where they get it from? Any idea?
From the pole?
No. They get it from a factory. From a factory. Factory makes the electricity just like a factory makes a car or makes anything else. This factory makes the electricity, and we call this a power company. A power company. Makes the electricity, puts the electricity on the wires carry the electricity sometimes a long, long ways. Were you ever driving with your mommy and your daddy and you see these really, really big, they look like metal skeletons, big things sticking up, these big wires. Did you ever see those?
Yeah. No.
Who never saw them? You never saw those big towers? They sort of stand up like this and they're out like that and wires are dangling from them.
Look like a T.
Yeah, look like a T.
Oh.
Yeah, you know what I mean. They're coming from the power company. They're carrying electricity. And that's how the electricity gets. There's a company that makes the electricity, puts the electricity on the wires. These wires go a long, long, long way. They go to everybody's house. They come over here to the school. They go to the pole. They go into the school. They go through the walls. And they come down there. You plug in your light, or you plug in your vacuum cleaner. You got electricity. I'm going to show you a power company. We're going to make our own power company here in a few minutes. I want to talk to you about the second kind of electricity. Not about wall electricity. I want to talk to you about battery electricity. You all heard of a battery? You know what a battery is?
Yeah.
What do you use batteries for? What? Running the race car? What else? Yeah, that's toy. What else besides toys? What else besides toys? A what? Yeah, what kind of a truck? You mean a people truck? Well, yeah, a people truck. You know what a battery does? Like a pickup truck, you know? Who has a pickup truck? Did you know your pickup truck had a battery in it? What does the battery do? What does the battery do? Yeah. Anybody, what's your name? Matt, anybody give Matt a hint about what a battery does? Yeah, what does a battery do? Well, it really doesn't. You know, what really makes the car go is the gasoline. What the battery does is it's what starts the car. It gives you, guys, what you were going to say? It gives you electricity to start the car. Now, I'm going to, all the time I'm here, I'm going to use about 4 words that I haven't, well, you might not know what they are, so I'm going to tell you exactly what the words mean, so you'll understand and you can do the experiments right. 4 words. And here comes the first one. Terminal. Every battery has got 2 terminals. You see this battery? This is a battery. You see these things sticking out the top? What do you suppose they're called? Terminals. Battery's got how many terminals? 2. One terminal the electricity comes out of, and it goes someplace. Whatever you connect the battery up to. And then the other terminal, it comes back in. 2 terminals, every battery, one where the electricity comes out, one where the electricity goes in. Kavish?
Kavish.
All right. Now, here comes our first experiment. In order to do this experiment, I got to tell you about this. This is a meter. This measures electricity. Now, this meter works sort of like you would expect a meter to work. Can you see that little black needle? Can you see that little black needle there? Do you see that little black needle? If I move the meter back and forth, it shakes a little. You see it? Everybody see it? Now, when it's not measuring any electricity, it's all the way to that side. All right? When it measures some electricity, it moves up a little bit. If it measures sort of a medium amount, it moves up more. And if it measures quite a lot of electricity, what do you think it does? That direction. Okay? Now, what I'm going to do is I'm going to connect this battery up, the terminals of a battery, and we're going to measure the electricity. And let's see, I need a volunteer. Okay, maybe this guy will. What's your name? Casey. Okay, Casey. What I want you to do, Casey, is when we connect up the battery to the meter, and the needle moves, I want you to take this pen and put a little line right on the glass so we know how far up the meter needle moved. Okay? All right. Now, I am going to measure this battery. All right? Is it okay if I put it here? Put it here. You put when I tell you, you put the mark on the meter, okay? All right. You see, it's not reading anything now, and now it is. You see it? Can you everybody see it? Okay. Okay. This is where the meter needle moves. Dixie, you come on over here and you stand up and you hold it up here like this, okay? Just hold it way above your head. You won't drop it, will you? Is that too heavy for you? Okay. I'm gonna make the meter. I'm gonna measure this battery, and let's watch the needle, everybody. Can you all see it?
No.
Okay. I'll tell you what. Move back a little bit. Okay. Now you come right over here. Everybody else stay in your seat. You come right over here so you can see it. All right. You all set? Now can you see it? Okay, everybody, here we go. You see where it went? About where Casey's holding where he put the mark. You see that? Okay. Let's just hold the meter for a second, Casey. You're doing a really great job. I really appreciate it. I have another battery I'm just going to let those dangle. You can hold that for a second, okay? I have another battery I want to show you, because I told you before that all batteries, let's just hold this right down here for a second, because I got to talk a minute, you won't probably get tired. You better think up. All batteries have how many terminals? 3? 2. Here's another battery. Has anybody ever seen a battery like this? You ever seen a battery like this? Who can tell me what it's used for? Yeah, watches. It's a battery in a watch. Now you see, it's a lot smaller than the other battery, isn't it? But it's got two. These terminals are kind of hard to recognize. The bottom is really a terminal, and the top is a terminal. They don't sort of stick out like they do in the big battery, but it's got 2 terminals. But it's very, very small, and it goes in a wristwatch, or it goes in a calculator. That's what makes the calculator have its power. That's where it gets its power. We're going to measure the electricity in this battery. And I want to ask you now, what do you think it's going to show on the meter? More electricity or less electricity than this battery? Okay. Whose idea is it that it's going to show less? Raise your hand. All right. Whose idea is it? Okay. Put your hand. Whose idea is it that it's going to show more? Not a single person. Okay. Let's do our experiment. Now, can you hold that meter up so everybody can see? Well, I'll tell you what. Why don't you just look at the meter, and wherever it goes, you put the mark. Okay? And then we'll hold it up. You ready? Okay, now. Okay, now. Well, it just it didn't settle down. It settled down right now. I'll tell you what. Let's put it down here. Take your hands off it, so because when you move it, it shakes it up a little bit. Okay. Now go ahead and now put the mark. All right. And it's not this one right. Tell you what. Let's get the right one. That's the one, right? Look where it went, everybody. Over there. Does that mean more or less electricity? Yes. Let's show you again. Now you hold it up so everybody can see it. Here we go. Is it more or is it less? Less. Right? Yes. So you were all right, huh? You got it right. But let's do one more experiment. Has anybody ever seen this? What's this? What's it got on top?
2 terminals.
One for electricity to come in, and what happens? Whose idea is it that this has more electricity than this one? Who thinks it has less? Now let's do the experiment. If it has more electricity, it's going to go, where's it going to go? All right. Now you hold this all the way up, okay? Everybody can see this. Here we go. More electricity. You were wrong. You see, you made a guess. Scientists have a fancy word. Thanks. Hey, you did a great job. Scientists have a fancy word for that, but it was a guess, and we did an experiment, and your guess turned out to be wrong. That's basically the way science works. You take a guess. I mean, some people are better at guessing than other people, and then you do the experiment, and then the way the experiment comes out, that's the way things are. That's the way science works. Okay, you can sit down. That was a real big help. Now, when we're finished, at the end of my experiments, I'm going to put the meter here, and you can come up and measure the batteries yourself. Just remember, you put one end of the battery to one terminal, and you put the other end of the battery to the other terminal, and then that's how you measure how much electricity there is in the battery. Now I have I have some other batteries here that I sort of, I take together. This is two batteries stuck together. Can you all see that? The terminals on this battery are like on that small battery, one at the bottom and one at the top. So electricity comes out of the top, goes to wherever it's going to go, and comes back in the bottom. I'll show you what I mean. Suppose we take a light bulb. Light bulb? Now I'm going to connect this light bulb up to the battery, and we should see that the light bulb lights, and that's what we think is going to happen, right? Okay. There. Why didn't it light? Why didn't it light? Just use one end. One, what's the word? Not end, so one terminal. Now, what happens if I touch the other? Voila! Let there be light. Now, I told you there were going to be 4 words. Here come, the first one was terminal, here comes the second. You only get electricity. You only get electricity if you have a circuit. Circuit. What a circuit means is the electricity comes out of the battery, goes through whatever it's going to go through, in this case the light, and then it comes back into the battery. There we have a circuit. Now we don't have a circuit. Why not? Because there's a gap between the wire and the terminal. Circuit's not there. It's broken. It's open. So you have to have a circuit to have electricity. There's a circuit. There's no circuit. All right? Okay. Suppose I take two, well, here's another light bulb. See that? That also makes circuit, no circuit. What happens, do you think, if I connect these two light bulbs together? Okay, here comes it. Well, I connect them together, and I make a circuit with both of them together. Will the light bulb, this is what the light bulb looked like if you remember when there was just one light bulb connected up. See that, how bright that is? Memorize that. Sort of put that in your mind and sort of remember. See that? See that? Now, here comes the experiment. I'm now going to make a circuit with 2 light bulbs. When I connect this terminal up, the electricity is going to have to go through one light bulb, down through the wire, through the second light bulb, back through the wire, into the other terminal. That'll make the circuit. Here's my question. Will these light bulbs be brighter, or the same, or not as bright? Okay. Who says they're going to be brighter? Okay. Now, who that says they're going to be brighter can give me a reason why they think it's going to be brighter? More electricity will come out? Well, that's a reason, but let me ask you to think about this. How much electricity do I have?
2 batteries.
2 batteries. Now, you see, I'm not changing the number of batteries I have. I'm changing the number of lights. So it's the same amount of electricity. It was kind of a good guess, but it just wasn't right. Anybody else that thinks it's going to be brighter? Have a reason for thinking it? All right. Who thinks it's going to be the same? Can you tell me why you think it's going to be the same? Who thinks it's going to be weaker? Why is it going to be weaker?
Because the top is going to that ball, and that ball won't be on. And then when it goes to the wire, that other ball won't be on. And it goes to that ball.
Yeah. Yeah.
And it goes back in the back.
That's what's going to happen, and I think that's pretty close. That's pretty close to the right answer. I think the electricity now, instead of going to one bulb, is going to go to 2 bulbs. You know, it's sort of like if you had a candy bar, and you ate the candy bar yourself, you'd have one candy bar, and then you need it. But if there was a friend, and you split the candy bar in half, and gave half to your friend, and you ate half, you'd have less candy, right? Well, you know what? This electricity's going to work the same way. The electricity is the same amount of electricity because we haven't changed the battery, but it's going to have to go to 2 light bulbs now. And since it has to go to 2 light bulbs, only half as much goes to each one, and as a result, weaker. You got it right. Okay, now that you know that, I want to ask you, what's going to happen if I put a 3rd light bulb and I connect the 3rd light bulb up? What's going to happen now? What do you think? It's going to get even weaker? Why is it going to get weaker? Because the same amount of electricity. Now you have 2 friends that you're splitting your candy bar with. Now you're only going to get a 3rd, right? It takes 3 parts now, right? Okay. Now I'm just going to remind you. This is what it was like when we saw our 1 light bulb. See that? See that? 1. This is what it was like when we saw 2 light bulbs. Okay. Now, there's 3 light bulbs. There's 3 light bulbs. What's the matter? What's the matter? What's the matter? Yeah, but there's no light at all. Terminal, yeah. There's no that word, the second word, there's no circuit. Now I'm going to make the circuit by connecting the other end of the wire and can you see that? You see that? It's weaker, isn't it? Isn't it weak? Do you all think at the end you paid enough attention so that you could do the experiment yourself? You think you could? Okay. Remember I told you that we're going to make our own power company now, and since you know about the circuits and you know about terminals, we can do that. So let's make our own power company. Now, to make a power company, I'm going to need. Will you help me? Will you come over here? Now, this is how a power company works. Let's see. You can hold the red wire right there. Okay? And face your glass, okay? Now, what we have is Heather is home at night. Heather is home at night, okay? And she, it's after school, and she went home, and of course, being a good student, she's going to do her homework. But it's sort of cold and windy out, and it's kind of dark, so she has to turn on the light. Well, in order for the light to work, she's going to have to have electricity. So, you know, at home we use lights. We use wall electricity because it's a lot easier and a lot more convenient because batteries wear out all the time. But the electricity comes the same way. Let's see here. She's there at home, and she is going to. Can I get by where you are? Wait, she is going to stand there and sit down. Can you hold that wire for me? She's there, and she wants to read a book, but she doesn't have any light. She needs to turn the light on. So she's going to go to the wall, and she's going to turn on a light. And while she's turning on the light, she is hoping that there will be. Will you hold that light for me? Okay. She's hoping that the power company will supply electricity to her so that when she turns on the light, let's see now, can you hold that wire? Now if I pull a little bit, you don't like that, okay? You just hold on. She has to have light so that she can read. wire so it doesn't fall down? Right there. Okay. Okay. Now, you hold up. Okay. Now Heather's at home and she's reading. She's reading. Now you hold the other end right about where my finger is, right there. That's it. And hold it up so that people can see the light bulb. All right. Now, she's at home and she's reading. And everything is fine. She goes to turn on the light, and what? You see what happened? The electricity is coming out of the battery terminal. It's going along this wire, going a long, long way. It goes through the light so Heather can read. I mean, if she didn't have a light, she couldn't read. And then it comes back, and it comes all the way through the wire and comes to the other end of the other terminal of the battery. You see that? Your power company works the same way, only the wire is a lot longer from one side of the room to the other. Now suppose, now let's suppose that Heather's sitting there reading, okay? And she's minding her own business, and she's just reading, and all of a sudden a big storm comes up, and it blows down the wire. What happens? So what happens? The power company sends out a man, he goes to the top of the tower, he finds the wire that's broke, he connects the two wires back together again, and let there be light. Let there be light. You see that? Your power company works exactly the same way. Boy, you did great. Thanks a lot. That's wonderful. That's wonderful. You can sit down now. I'm going to have these light bulbs up here, and at the end, you can all come and do this kind of experiment, okay? But before we do, I have got to take back my popcorn. Did you think that the electricity could travel that far through a wire? Did you know that? Okay. All right. Now, you did a great job holding that. I appreciate it. You were sort of my own telephone pole. You were sort of my own telephone pole. Okay. All right. You did a great job. Huh? You did a great job. Okay. All right.
She didn't have any wire at home.
I want to show you something else now. Now, listen, everybody stay where you are, okay? Because what I'm going to do is I'm going to come around and show you how to do this experiment so you know how to do it, okay? I'm going to come around. This is called a compass. That's the name of this thing. And I want to show you guys first something about this compass. If you move your hand like that on the compass, does it make the compass move? You try it. All right, now watch me. Well, how am I doing that? Got a magnet in my hand? You think that explains it? I got a magnet in my hand?
Yes.
If you move your hand back and forth, does it make it move? Mine does. You can see it?
Yeah.
See that? All right, you're right. Here it is. I got a magnet in my hand. But I got to ask you something. Let's see. Okay, can I leave this here for a few minutes? That'd be right. I'm going to ask you something. Why is it that the magnet Why is it that the magnet makes the compass move? Why? Can you tell me why?
Because on some compasses it has that little needle and it's metal.
Yeah.
And the magnet, the metal has that, the magnets.
Well, that's sort of part right, but it's not altogether right. The reason I'm taking the magnet down to Mr. Marino's desk, okay? Because I got to put it someplace where it won't roll off. And what I have here is a paper clip. You see that paper clip, everybody? Paper clip. See that? The paper clip. At the end of a piece of string, and if I put the paper clip near the magnet, you see what happens? It sticks. Okay? It sticks. What? You think there's glue on the magnet?
No.
What is it that makes the paper clip stick to the magnet? This I got it. I have to tell you. This is a kind of a hard one. This is kind of a hard one. What is it? Well, that was a good guess because we've been talking about electricity. And it is something that is close to what electricity is. It's not electricity though, it's magnet. Actually, it's a magnetic field. Magnetic field. I'm going to show you an experiment at the end where electricity and magnetism sort of get turned into one another in an electromagnet. But that's another story. A magnet has sort of a space around it, and it can reach out and it can pull things toward it. It can like pull paper and plastic, things like that.
No.
It only pulls very certain special kinds of metal. Mostly for all practical purposes, iron. The magnetic field pulls iron. It doesn't pull other kinds of things, and that's what I want to show you right now. Suppose we can you all see this paper clip here?
Just tie it
Okay. All right. See, you guys come over here. You guys come
Are
over
these
here.
all for my class? Just this one?
You guys come over
Okay,
here.
do you want to just leave it there?
Watch
Fill
this.
it, put it on the desk. Easier to find it. Okay. So just point it toward it. It's filled in. Is it easier if I shove it?
Yeah. You see what's
I can
happening?
see better.
You see what's happening?
You can get up closer.
What's making that paper clip stand up? Can you see that? What's making a paper clip stand up? What? Okay, it's the magnetic field. Now, wait a minute. I want to tell you something about it. Okay, now wait a second. I want to tell you something about it. This magnetic field, it's coming out of the magnet, and it's reaching out right through the air. And it's grabbing that paper clip, and it's holding that paper clip up. And if I push it down, look at that. Right back up again. Now here comes our experiment. Will that magnetic field go through a finger? Wait a minute. Will it go through a finger? That's my question. What do you think?
Yes.
Why do you think that?
I went to this other place and they showed me that it could.
You've already done the experiment.
It hold other people's hands and it. The last person in the row that's not holding someone's hand, they'll get a sort of like a funny feel and they'll tickle. It'll feel sort of like a tickle.
Okay, well let's see if you can. Let's put your finger very carefully and see if it knocks down the magnet. Now put it down in between the magnet and the paper clip. Look at that, right through his finger. You see that? Right through his finger, and it doesn't change. The magnetic field goes right through his finger, just like it's not there.
Let me see.
How about a piece of paper? What if I put a piece of paper in between? Will that block the magnetic field?
Yeah. No.
Okay. Right through the piece of paper. Magnetic fields go through almost everything except for iron. That's the only thing that blocks them. Okay, everybody sit down. Okay. I'm going to leave this here, and we'll come at the end and do an experiment, okay?
Sit down.
I like that light.
Listen, everybody sit down. Everybody sit down. Everybody sit down. This compass, I'd like most of you guessed, this compass that I put down here and showed you, this compass, it measures when there's a magnetic field present. So when you move the magnetic field around, it makes the compass move. The magnetic field comes out of the magnet, and it reaches over, and it can affect the magnet that's inside the compass. So you can, even though you're not even touching it, you can make it move. That's the thing about electricity. Even though something isn't touching something else, electricity can still make it move. See that? Now, do you think you saw enough of that so that when at the end you can do your own experiment?
Yeah.
Okay. I'm going to put it up here for now, but in a few minutes I'm going to come around and I'm going to show you. I'm going to show you how to do it. There's one compass. Here's another compass. I'll put this on another table, and somebody can take a magnet and can make this compass move. And then here's another one. So you'll have different experiments at different places in the room. Okay? Okay. But before I do that, there's two other things I want to show you. And this is one of them. The thing about electricity is it can get turned into other things that you know about. Here's one example. I need, how about you? I want you to put your fingers on that, to hold that, okay? Now, after I connect it up, I want you to tell me, nothing's going to happen right away. Everybody's going to be listening to you. And I want you to tell me if you feel anything at all. Okay? Here we go. Connect it up. Now it's connected up. Let's wait and see what she says. Well, wait a second. It's got what? It's getting hot. Electricity can make heat. Electricity, when you do this experiment, you don't need to turn off the compressor, otherwise you burn your finger. So it gets warm now. Feel that now. You can see it's kind of warm. Electricity can make heat. See, electricity can turn into other things. It can turn into heat. Now I want to show you the last experiment, what it can turn into. And you kind of got to pay attention to this pretty close, because I can't do this experiment too long, because it sort of uses a lot of electricity. But I have already shown you that magnets, magnets pick up pieces of metal, right? See that? See that? That's what magnets do. I can take them off, but then, by the way, having done this in front of you, what does that tell you that these paper clips are made out of?
Metal.
They're made out of metal, but any ordinary kind of metal?
Iron metal.
Iron metal. Why are they made of iron metal? Because they stick to the electromagnet. They stick to the magnet. Gabish? All right. Now, here comes my last experiment. This is a little machine, and it's not a magnet because I can touch it to the paper clips and it doesn't pick them up. I just showed you. Remember a moment ago how we touched the magnet to the paper clips and it picked them up? You see, this doesn't. You see that? So it's not a magnet. But this is an electromagnet. What that means is, when I connect this up to electricity, it's going to turn into a magnet. Now here we go. Here goes the experiment. See, I touch it, nothing happens. Now watch what happens when I connect this up to the electricity. See that? Okay. This disconnect electricity. Can you just grab that and squeeze it and lift it off? See that? Okay, connect it on again. Okay, connect it off again. See that? It makes an electromagnet. This is a magnet only when the electricity is flowing through it. If you turn the electricity off, you don't have a magnet. This magnet stays a magnet all the time. It's a magnet forever. In fact, when you come up at the end, you might want to take a look at this. This, huh?
It's a magnet.
Yeah. This magnet differs from this magnet. You know how? This magnet was made in a factory. You know where this magnet was made?
I know.
Where?
It was made by people in China.
No. It was just a rock found in the ground. It's a special kind of rock that's found in the ground that's a magnet all by itself. Now, it's not as strong a magnet as is the magnet that was made in a factory, but it's still a magnet. And when you come up and do the experiment, you can make the compass move. That'll be the proof that it's a magnet.
What's the name of that stone we saw it in the movie yesterday? What kind of a stone?
Lodestone.
What is it?
Not a lobster.
Yeah! Lodestone.
Remember?
Lodestone. This is a natural magnet. Natural magnet. This is a magnet that's made in nature. You just find it in a mountain. That's a permanent magnet, but it's weak. This is a magnet that's made in a factory. That's permanent and it's strong. This is an electromagnet. In order for this to be a magnet, you need batteries, electricity. Exactly right. Okay. Now, what I'm going to do is I'm going to put some of the experiments on each table. All right? 1, 2, 3, 4, 5, 6. There's one experiment on each table, and you do that experiment, and when you're done, we'll switch to the next. You can leave the experiment there, and you go to the next experiment that you want to do, and the other people will come to your experiment, okay? And I'll come around and I'll help you with it, okay? All right. I'm going to leave this here, and this, and be careful. Don't leave it connected too long, because it uses a lot of electricity, okay? All right. Here's an experiment with 1 and 2. You can connect it, make your own. You can make your own. Here's an experiment you guys can do. Make your own. All right. Experiment you can do. Make the compass move. You can make the compass move. Okay, we need an experiment for you guys, right? All right. Who doesn't have an experiment? Everybody got an experiment? Okay. What? No. It just works for that. Now watch. You put it down. Now you gotta kind of move this. See how it follows? See? If you move too fast, it won't. See that mag? Yeah, it's too fast. Here, you can do it. Absolutely. You gotta connect this up to the little black one to that one. Just touch them and see what happens. Watch the meter. See? Let her try it. I'll get you another battery. Everybody doing okay?
Yeah.
Everybody's trying the experiment. You can go and try another.
Can we play that work together?
That's you have to touch one to this side and one to the other side. Now, you moved the experiment now. You're supposed to stay, the experiment is supposed to stay here. Anybody who wants to do the experiments can come and do it. But don't move the experiments. Let me show you how this works. If you take one wire, just hold it on. See there? Take the other one and hold it there. See that? Another way to do the experiment would be to just go through one light bulb. Now you get one light bulb. Another way to do the
He's almost through.
one or two or none of them. That's just the one. No, not too big. There you go. You did a good job. Okay. I'm gonna get it. That's where it's at. We need to borrow the battery for a second so we can do this experiment, okay? See how it's kind of cold now. See that? Remember that? Did you make that measurement? Did you measure that battery? It's kind of hard to do. Let's do it this way. Suppose I hold it, and you just...